Hello everyone, welcome to today's class on computer science for class 12. I am Yashita and in this video we will begin with chapter 1 Python revision tool based on Sumita Arora's textbook. This chapter is the foundation for understanding Python programming. Basically we'll be revising all the topics of class 11th in this chapter. We will cover the basics like what Python is, its features, built-in data types, expressions, flow of controlling programs. Okay, let's get started. Okay, so we'll start with the introduction. Python is high-level interpreted general-purpose programming language. Okay, so what do we mean by interpreted? It means that it runs from line to line and no separate compilation is needed. So in compiled languages like C, C++, or Java, the entire program is first translated into machine code. Machine code is in the form of zeros and ones. So the entire code is first translated into machine code by the compiler and it produces an executable file. Only then the program is run. Even if one line changes, the entire program is recompiled again. But in interpreted languages like Python, there is no separate compilation step. The interpreter reads your code line by line, translates it to machine instructions and runs it immediately. So this is the reason why we say Python is very fast. Okay, so Python was created by Udo van Rossum in 1991. It is a very simple syntax and it's easy to read and learn. Python is used in web development, data science, artificial intelligence, automation, and game development. So we see Python is used extensively these days in data science and artificial intelligence, and it's a very versatile language. So I'll just quickly show a very basic Python program. Let's just move to IDE. Okay. So I am using PyCharm IDE for writing code. IDE is integrated development environment. You can use any IDE of your choice, be it PyCharm, VS Code, whatever you feel comfortable with. If you do not have installed any IDE, then I suggest you to install one. You can refer any basic YouTube video available online in order to install it if you don't know how to do it. Okay, so I'll show you how to print a very basic Hello World program. So this program will print Hello World. Alright. See. So just with the help of this print, which is a built-in command in Python, we are able to get the output Hello World here. Alright. Moving forward. Okay. Now we'll see what are tokens in Python. So tokens are the most basic unit of a program. These are smallest building blocks of Python program. So like in a sentence, we see there are a sentence is built using different words combined together to form a sentence. Similarly, tokens combine together in order to for creation of program, right? So what are the different types of tokens? So we see there are multiple types of tokens like keywords, identifiers, literals, operators, punctuators. These are all different types of tokens and we'll be learning about all these in detail. So I'll be using this particular example in order to explain you tokens in a better manner. I'll just first quickly write this program on our IDE and then I'll show you. Okay, so we'll write name equals to Alice, age equals to 18. If age is greater than equal to 18, then what will print? Will print name is an adult, right? Else what will print? Will print name is not an adult, right? So let's just run this program. Alright, so since we had given age equals to 18, so this program prints like when it compares if age is greater than equal to 18. So age is equal to 18, yes. So we'll jump here and we'll print is an adult. Alice is an adult. So if age was less than 18, let's say if age was 9. Okay. So if Alice was 9 years old, then it says Alice is not an adult, right? So, okay. So, I hope this is a very simple program and it's clear. Okay, let's just move back to our slides. So, we'll come back to tokens. So, what are keywords? Keywords are reserved words with special meaning in Python. Keywords cannot be used as variable names because these are reserved words and we cannot use them as variable names. So like if, else, true, false, all these are keywords, right? Can you quickly identify what are the keywords here in this program? So we can see that if and else, both these are the keywords. These are the reserved words, right? Okay, so we will see what are identifiers. So identifiers are name given to different parts of a program, like variables, functions, classes, objects. Whenever we assign any variable or function, so we are supposed to name them. So the names that are given to them are identifiers. So we have certain rules for identifiers, like they can't start with a number, no spaces or special characters, case sensitive. We have example like a name and age. For example, we can see in this program, name equals to Alice, age equals to 18. So these are name and age are both identifiers, right? Okay, now we'll see literals. Literals are the fixed values. They stay the same during the program. Okay, so we have different types of literals. Like we have numeric literal, like integer, floating point, complex numbers, integer in the form of 10, 25, floating point numbers, which are decimal numbers, complex numbers, which have real and imaginary parts. So these are all numeric literals. Then we have string literals. String literals are whenever we assign a value string. For example, string are written in the form of either double quotes, like name equals to Python. So Python here is a string literal. Multi-line string, these basically are used for writing comments in Python. Whenever we are supposed to write comment with big comments which cover two, 3 lines, so we can make use of multi-line string. Then we have Boolean literal. These are like true or false. Then special literal, which is none. So we can see here name equals to Alice. So Alice is a string literal and 18 is a numeric literal. Okay. So now we have operators. So operators are special symbols used to perform operations. Types of operators, like we have arithmetic operator, plus, addition, subtraction. Then there's relational operator, which is equal to, not equal to, greater than, less than. We have logical operator, and, or, not. Like if we have both the conditions are true, then we'll make use of and. If at least one condition is true, then or. If we just want to reverse it, then we'll make use of not. These are all logical operator. Then we have assignment operator, like when we assign equal to, like age equals to 18. This was an assignment operator. Or add and assign, subtract and assign. Then we have bitwise operator, bitwise and, bitwise or. Membership operator, like in, not in. If we have to check whether any particular value is present in list. So we'll write it if 18 in this particular list or not in this particular list. Membership operator. Identity operator is not. Okay. So these are different types of operators, and if we'll see in this program, what are the operators? We have this assignment operator equals to, like name equals to Alice, and we have this greater than equal to, which is a relational operator, like greater than equal to, right? Okay. So next is punctuators and delimiters. So punctuators are used to define the structure in Python, like we saw colon, comma, brackets. These are all punctuators, and we need them to define to write our program with in a certain form, like in well-defined form. Okay. So now we learn about bare bones of a Python program. So a simple Python program has 4 parts: comments, statements, indentation, and functions. So what are comments? These are used for documentation purpose. These comments are not executed when we run the program. We just write them in order to so that our program is more readable. Okay. Statements, these are the code lines that are executed by Python line by line. So all these statements, the code lines which are basically executed whenever we run the program are statements. Then we have indentation. Indentation is for defining code blocks in Python. So all the spaces and caps that we use in order to create a proper structure of a program, that is called indentation. Then we have functions. In Python program, we use functions for writing organized code. Okay, and functions, we can call functions multiple times. So in order to create a program where we don't have to repeat lines multiple times, we can write a function and we can call that function multiple times. I'll just show you on IDE. Okay. Comments. So comments are usually written in this way using hash. This program checks number is positive, negative, or 0. Okay, so this was the comment. Then we'll write statement. Statement is variable assignment. So we are assigning the variable as num equals to 0. Next, we'll write with indentation. Alright, so if num is greater than 0, we will print positive number. Else if num is less than 0, that case we print negative number. Else we print 0. So here we have written this code and we have used these spaces here. So these are indentation. So we cannot write like this will give us an error. Okay, so in order to write in a proper format, we have to follow this particular structure. All right. Now next is, we'll see function. All right. Okay, just write a simple function. Define greet, and here we'll print hello from Python Barebones. Alright, and I'll just show you how this function is called here. So this is the function call. Alright, so here the number was 0. Okay, once we move into these lines, we'll see if number is greater than 0, positive number; if number is less than 0, negative number; if number is equal to 0, then 0. So that is why we have here 0 is printed over here. Alright, then we have called this, we have created this function, and here we have called it. Because we have called this function, so this, it has printed hello from Python Barebones. If let's suppose I have commented the function call, so here we'll say only 0 is printed. Okay, all right. We just move to the slides now. So next is variables and assignments. So what is a variable? A variable is a name given to a memory location which stores the data. Let's say we have this variable age equals to 18. All right. So this particular, whenever we are assigning this variable age, and we are assigning this value 18 to this variable, so there's always Python assigns a memory location where this memory value is stored. Alright, let's say this memory location is like x66, let's say 3421. It could be any memory location. So there in this particular memory location, this value 18 is stored. Okay, so this is what do we mean by variable assignment. Here equal to operator is used in order to assign values. In Python, multiple assignment can also be done. Example, dynamic typing. There is no need to declare data type explicitly. Type of variable is declared at runtime. And then we have static typing. In static type, we declare the data type in the starting only. So, okay, I'll just explain you with the help of example. So here dynamic typing, we said x is equals to 10. Here when we are assigning value x is equals to 10. So this is an integer. Then we are reassigning x equals to hello. Now this is formed. Now this has become string. So the memory location earlier, the memory location which stored 10, x was pointing to that memory location. Now x is pointing to hello. I'll just show you. Let's say here in this particular memory location, x was earlier pointing to this particular memory location. Now x is pointing to that memory location where this hello is stored. Okay. Next we have static typing. In case of static typing, we are already saying int x is equals to 10. So now if we reassign x is equals to hello, it will give us an error type mismatch because we have already assigned data type of x and it should be int. Alright, so this is the basic difference. Let me just show you on IDE how it's done. Okay, let's just make a new file and we'll call it variable assignment. Okay. Okay, so if we write name equals to Alice, age equals to 18, print ID name. So ID will print the memory location at which this particular variable is stored. Print ID age. Okay. Alright. Okay, I'll just run it. Sorry. Okay, so here we see this is the memory location of this variable name and this is the memory location of this variable age. Okay, so these are two different memory locations that are assigned for these two particular variables. Okay, now I'll show you multiple assignment. So let's say if you have A equals to B equals to C and all three of these variables have common value 10. So we'll just show print ID A, print ID B, print ID C, and I'll just comment out these. Okay, let me just run it here. Okay, just look at here. This is the memory location of A, this is the memory location of B, and this is the memory location of variable C. And all of these have same memory location because they are all pointing out to same value. Okay, because 10 is stored here in this memory location and they are all referring to this particular memory location. Okay, I hope this thing is clear. Okay, so now next part is simple input and output. In Python, for inputting the value we use input function. Okay, and for printing the value we use print function. By default, input is taken as a string, and if we want input to be an integer or any float value or whatever value we want, we have to explicitly specify it. We have to change it. Okay, I'll show you what I mean. Okay, let's say name equals to, we will be inputting the name. Okay. Enter your name, print okay. So here what we are doing, we are taking the input. We are asking it to input the name. I'll show you. Here it is asking us enter your name. Let's say name is John. Okay, so here it has, we have got the output, hello John. Alright. Okay. So using input, we are taking the input. Using print, we are displaying the result. I hope this thing is pretty clear. So now we'll move to data types. So what are data types in Python? So in Python, we have built-in data types. For example, numbers. So numbers are used to store numeric values. So these are of type int, which are whole numbers, float, which are decimal values, and complex numbers with real and imaginary part. So we have integers like 10, 20, floating values, we have like 4.35, which are decimal values. And then we have complex numbers like, 3 plus 2j, where this is the real part, this is the imaginary part, right? So these are the numbers. Okay, so next is strings. Strings are a sequence of characters enclosed in single or double or triple quotes. For example, we have hello or Python, which are written under double quotes. So these are strings. Next, we have list. List are a ordered collection in Python. These are represented by square brackets. So like list in Python are mutable. The state can be changed after creation. So what it means is, like, for example, we already have a list of fruits called fruits. Like in this list, we have 3 elements: apple, banana, and mango. Now let's suppose we want to add another element, let's say guava. So we want to add guava here. So we do not have to make a separate list in order to do so. We can make changes in the same list because lists are mutable in lists are of mutable type. So the state can be changed, and it is possible to add or remove elements from a list, or to reorder the elements of the list. Okay. Next, we have tuple. Tuple are ordered collection in which are represented by these brackets. Tuples are immutable. So tuples are immutable. It means that it cannot be changed. So if, like, let's suppose we have a tuple called fruits, and these are the 3 elements. Now, if we want to add guava here, we cannot do so. We'll have to make a separate tuple in order to do so. That because tuples are immutable in nature. Then we have sets. Set is a collection of unique unordered collection. So sets are unique because it cannot have duplicate value. So for example, there is no duplicate value is present. 1, 2, 3, 4, 5 is there. If we cannot add another 5 here because we cannot have duplicate values. Plus these are mutable in nature. So the sets are clear. Then next is dictionary. For dictionary, they are stored in key value pairs. They are represented by curly braces. For example, name Ria, age 17, marks 92. So it's a dictionary. All right. So we'll be all these data types. We'll be learning about them in great detail in the next chapter. Right now, we're just looking at the basics in this chapter. Okay. Now next is mutable and immutable types. Okay, we just saw that int, float, string, tuple, these are immutable in nature. But why are these immutable in nature? Because they are stored at a fixed memory location once they are created. And if we try to change the value of a variable, then it points to a new memory location, which stores the new value. So what it means is, like, for example, x is equals to 5. Now, if we say we want the value of x to be 15. So earlier the memory location it was referring to was the one which had 5. Now it will refer to a separate memory location. So when we try to change the value of a variable, it points to a new memory location which stores the new value now. Alright, and the old object is discarded as no variable is pointing to it. So we will discard this value because this was the previous value, and now x is pointing to this new value. Okay, I'll just show this example again on IDE. So now I'll create a new file. Let's see, Mutable. Okay, I'll show you what I mean. Okay, here we'll see the example where I'll print the address of location x when the value is 10. And okay, so we'll just run it. So here, right now, if we see, when x equals to 10, the memory address is this. Okay, so now we'll change the value x is equals to x plus 5. Now again, if we print the address of x, now this is the new address of x. Alright, which is different from the previous address, right? So that is why whenever we change the value, it points to a separate memory location, and the previous and the value like which is it was pointing to previously, that value will become the garbage value. Alright, that is why immutable objects cannot be updated in place. Okay. Going back to slides. So next, what are mutable types? Mutable types such as list, dictionary, set are stored in the memory as container objects. So what it means is, like whenever we modify the content of a list or a dictionary, we don't have to create, it does not create a separate object. It still points out to the same object, only the content of that object are changed. So because these are container objects, memory address ID of the object remains same. So here I'll show you what it means. First, let me just comment out the previous code. Okay, let's say we have list 1 and this list has these values 1, 2, 3, 1, 2, 4. Now we'll just print the address of list 1. And let us see what is the address of list 1. So the address of this is the address of list 1. Okay. Now if we append this list, let's say list 1 dot append, and we are adding value, let's say 5 here. Now let us say how does it our list look like. Okay, let us just see the address of the list, if it is same or it has changed. See, so this is the address of the list, which is same as this address because the memory location is not changed. Only the content of the list has changed. Alright, is this difference clear? Alright, okay. So let's move to our next topic, expressions. Expressions in Python is a combination of values, variables, operators, and function calls that Python evaluates to compute a result. So anything that gives value is expression. So there are multiple types of expression. Like we have arithmetic expression. It helps to perform mathematical operations. For example, here if we have a equals to 5 and b equals to 10. So if we evaluate a plus b, so this is the arithmetic expression. Here we have variables a and b, and we are using this operator plus, and we are computing this expression which evaluates to 5 plus 10 equals to 15. Next we have relational expression. It helps to compare values. So here if we have x is equals to 3 and y is equals to 6, So obviously we can see that y is greater than x. So if we evaluate this expression, that is x greater than y, then it evaluates to false. Okay. So next is logical expression. It uses logical operator. And what are logical operators? These are and, or not to compute the result. So here we have x is equals to 5, y is equals to 6. And we are evaluating this expression x greater than 2 and y less than 10. So yes, x is greater than 2 and y is less than 10 because y is 6. So y is less than 10. So this expression evaluates to true. So here we have used and. So both these conditions should be true. If we say x is greater than 2 and y is greater than 10. So this expression would evaluate to false because we have used and condition. So both these conditions need to be true. Okay. Next is typecasting in Python. So what is typecasting? It is a process of converting one data type into another data type, so that the operations between variables of different data types can be performed. In Python, there are built-in functions to perform typecasting. So there are two types of typecasting: implicit typecasting and explicit typecasting. So in case of implicit typecasting, it is done automatically by Python. It converts the data type to compatible data type. So here I'll just show you the example. X is equals to 2.5 and y equals to 5. If we add x plus y. So what happened? It evaluates to 7.5. How? Because in this addition what happens? We have x is equals to 2.5 and y is int. So y will be converted automatically to float value 5.0 and then we'll compute it and the answer would be 7.5. Alright. So this is implicit typecasting. So here Python automatically converts integer 5 value to float 5.0 value to make the addition possible. Next, we have explicit typecasting. It is done manually by the user with the help of constructor functions. Some of the functions are int, float, string. So we have to manually do this. So for example, like x is equals to 100 and it is written under code, so it is a string. So what we'll do is we'll convert this into integer value. Y is equals to int x. So what is happening here? It is converting string to integer value. Only then we can add plus 10 to it because now y has been converted to integer value. Alright. So next is math library functions. So Python has built in math library which helps in many mathematical operations and we do it with the help of math function. Okay, I'll just show you on PyCharm. Okay. So first of all we'll import math function. Then what we are trying to do here is if trying to find out the square root of 16. We'll do it with the help of math function, which is this square root of 16. And let us just print it. Okay, so square of 16 is 4.0, right? Next is, I'll show you one more example. We'll try to find out what is the answer of 5 raised to the power 3. Right? 5 raised to power 3 with the help of math function power. So here we are trying to find out the power 5 raised to the power 3. Okay. Let us just print it. Five raised to power 3 is 125. Okay, so this is the answer. Alright, moving back to slides. Okay, so next we have statement flow control. The order in which statements are executed in a program are decided by flow control. In Python, code is executed line by line, but we can always change the sequence using conditions, loops, iterations. For example, when we write if-else condition, the code executes the if condition whenever it is true, and the code under the else condition is skipped because already we have executed the code under the if condition, right? Similarly, in case of loops, the code is executed multiple times according to the loop condition. For example, let's say we want to iterate it 100 times, so the code will execute 100 times, right? So with the help of this statement flow control, what we are doing is we are changing the flow of the program, right? So we have compound statement. A compound statement is a group of multiple statements that are combined together and executed as a block. In Python, compound statements are written with indentation. Okay, I'll just show you with the help of an example on Python. Okay, I'll show you the example of compound statement. X is equals to 10 if x is greater than 5. Print x is greater than 5. Print this is inside compound statement. Okay, so when we run this program, right, so we get the output x is greater than 5. This is inside compound statement. So what is happening here is it is checking it. We have assigned the value of x is equals to 10. Now it is checking the condition if x is greater than 5. So if this condition is true, we will be printing this entire block. Okay, so that is why it is a compound. That's what we read in the compound statement. So next we have simple statement. Simple statement is a single line of code that performs one action and no indentation or block is required. So it's a single line of code. Is simple statement. We have empty statement. An empty statement is a statement that does nothing. In Python, keyword pass is used to create an empty statement. So whenever if we are not sure what to write or what all code we need to write under a particular condition, so we can use pass for the time being, and then that condition nothing will be executed there. Okay, so it is just used as a placeholder where code is syntactically required but not yet written. Right? I'll show you with the example. Okay, so I'll show you the example of simple statement. Okay, x is equals to 5. Print x, y equals to x plus 5. Okay. So here the output is 5. So this is assignment statement. Here this is output statement and this is the expression statement. Okay, so this is the example of simple statement. Next we have empty statement. So let's say if we have a condition if true and we don't know what to write under this condition, the code we haven't figured out what code to write, so we can just say pass and then we'll print program continues. If we print this, then the output is program continues, because this we have already said we just need to pass it. Alright, this is the example of empty statement. So the next topic is if condition. So if conditions, we have seen if conditions, they are basically used for decision making in Python. So there are multiple types of if statement. Simple if statement, so it executes a block only if condition is true. So we see the if condition, and whenever that if condition is true, the block is executed. So there is no else condition here. Then we have if else statement. Here we have two blocks. One is for true, another is for false, right? So there are like if whenever if condition is true, that block of code is executed. Otherwise, under the else block, whatever the code is there, that is executed. The next we have if else ladder. So there are multiple conditions. Like we have if x greater than 0, else if x equals to 0, else if both of above conditions are false, then we'll come to the last else condition. Alright, so that is if else ladder. Then the last is nested if. So we have if condition, and under that if condition we have another if condition. So that is nested if ladder. So I'll show you the example on Python. Okay, let us first see the example of simple if statement. Okay, so if x is equals to 10 and if we say x is greater than 5, print x is greater than 5. Alright, I'll just execute it. I'll run it. So it prints x is greater than 5. So here we have a simple if statement. We have given the value of x, which is 10, and we are asking, we have a condition if x is greater than 5. So yes, the value of x is 10, which is greater than 5. So it will come here and it will print this statement. Alright. So this is an example of simple if statement. Okay. So next we have if else. So next we have if else statement. So here if we say x is equals to minus 3, if x is greater than equal to 0, then we print positive number, else we print negative number. Let me just comment this out. So if I right click here and run this code, so it gives me negative number because we had given the value x is equals to minus 5. So we here have if statement and else statement. So because first it will check if whether x is greater than equal to 0. So the value of x is minus 3, which is not true. So it will come here under the else condition, and here it will print negative number. Okay. I hope this thing is clear. It's an easy program. So next we have if, else if, else condition. Okay. So I'll just write marks is equals to 75 if marks is greater than equal to 90, print grade A, else if marks greater than equal to 75, print grade B, else if marks greater than equal to 50, print grade C, else print grade D. Okay, so here if we run it, we get the answer grade B because we have assigned marks is equals to 75. So first it will go here, it will see if marks is greater than 90. No, it is not true. So it will move directly here. If marks is greater than 75, yes. So it will print grade B. Okay, so we have all these conditions in if, else if code. Okay. Okay, so next we have nested if. Okay, so here we have x is equals to 20 if x is greater than 0. This is the first if condition. Next we have if x equal to 0. Okay, so what it is doing is it is saying divide x by 2, and if the remainder is equal to 0. So we get the remainder when we use this operator. Okay, so we print positive even, else we print negative even. Okay, so here we'll see. So x was 20. So yes, x is greater than 0. And when we divide x by 2, the remainder is 0. So we have printed positive even. If we make it 21, then what will be the output? It is saying negative. Sorry, here it will be positive odd. I'm sorry. Yeah. It will be positive odd. Why? Because x is greater than, so here we have, in the outer condition we have x is greater, x should be greater than 0. So number will always be positive. And because remainder is not equal to 0, so it will come here and it will say odd. So here answer will be positive odd. Okay. So I hope this example is clear. Okay. So next we have looping statements. A looping statement allows us to execute a block of code repeatedly until a certain condition is met. So we have a certain loop and that loop will continue running till we meet that condition, and only then we'll come out of that loop. Okay. So in Python there are two main looping statements, which are while loop and for loop. So first we'll see while loop. So a while loop in Python is used when you want to repeat a block of code as long as a condition is true. Okay, so we have this example. Count is equals to 1 while count is less than equal to 5. So this is the condition. While the value of count is less than equal to 5, the loop will go on. Once value of count is greater than 5, then it will come out. So while the value of count is less than equal to 5, what we'll do is we'll print the value of count. And here then we are incrementing the value of count. Okay, so I'll show you what this code is doing. So initially we have count is equals to 1. Okay, so it will come here while count is less than equal to 5. Yes, this condition is true. So it will print count is 1. Okay, next it will come here and it will increment the value of count. So now the value of count has become 2. So it will go here while count is less than equal to 5. Yes, value of 2 is less than equal to 5. So it will print count is 2. Then it will go here and again it will increment 1. So now the value will become 3. So again it will check the condition. Yes, the condition meets. So it will print count is 3. Okay. Now again it will increment the value. Now the value will become 4. So the condition is true still. So we'll print count is 4. Again it will increment the value. Now the value of count is 5. And we have a condition while count is less than equal to 5. Yes. Value of count is equals to 5. So condition is still true. Still the condition meets. So we'll print count is 5. Again it will increment the value 1. Now the value of count will become 6. Once the value of count becomes 6, it will go here. It will ask if count is less than equal to 5. No. So it will move out of the loop. Okay. So I hope this example is clear. So next we have for loop. So a for loop is used to iterate over a sequence like a list, tuple, string, dictionary or range and execute a block of code for each element. Okay. So I'll explain with the help of example. For I in range 5, print I. So here we say range 5. So it means we'll go from 0 to 1, 2, 3, 4. Okay. So 5 is the upper limit. So for I in range 5, print I. So what it will do it? The first will check for I, the value of I is 0. Then it will print 0. Then next we have value of I will become 1. So it will print 1. So similarly the output will be 0, 1, 2, 3, 4. Okay, because we have specified range 5. Okay, so next we have loop control statements. So Python provides special statements to control execution. So for example, if we have a loop and we want to break out of the loop or you want to skip certain part, so for that we need loop control statements. So in Python we have break statement. Break statement helps to exit the loop immediately. So what happens here is, like for example, we have like for I in range 1 to 10. Okay, so if I equals to 5, it will break. So whenever the value of I becomes 5, it will break out of that loop. Okay, so and we are printing the value of I. So the output for in this case is going to be 1, 2, 3, 4. Because as soon as the value of I becomes 5, it will break out of that loop. Okay, so I suggest you to run this code on your IDE and see for yourself. Okay, next we have continuous statement. Continue helps to skip the current iteration and move to the next. Okay. So what it means is, for I in range 1 to 6, if I equals to 3, continue, print I. So what will be the output? We'll be printing the value of I. So the value first it will print 1, then it will print 2. Then as soon as value of I becomes 3, it will continue. So that thing will print. Okay. We'll just go back inside. It says continue. So we'll just go back inside this loop and we'll say the value I will become 4. Then it will print 4. Then 5. Okay. So what continue is doing is, whenever we encounter continue, we'll just skip that current iteration. Okay. So next is pass. Pass is, it only acts as a placeholder. It does nothing. So for I in range 10, we are saying pass. So nothing, will not get any output. It will just skip this part. Okay. I'll just show you the examples of for loop and while loop on PyCharm. So first we'll see for loop. So what this program prints, even number, skips odd numbers and stop at 20. Okay. So we'll write the loop for num in range 1 to 31. Okay. So the lower limit is 1 and the upper limit is 30. It will go from 1 to 30. So if you say if num percent 2 is equal to 0, is not equal to. First condition is if num percent 2 is not equal to 0. Okay, so it will say continue. Why? Because we want to skip the odd numbers. Okay. If num equals to 20, we'll say print stopping at 20, and to stop it we'll say break. If either of these conditions are not true, then we'll say even num and we'll print loop continues. Okay, I'll just show you. Right. So what is the output here? Okay. So here the range is 1 to 30. Okay. So first it will check 1. Since 1 is the remainder, when we divide 1 by 2, the remainder is not 0. So it will continue because 1 is an odd number. So it will continue. Next, it will come to 2. Now 2, when we divide 2 by 2, we will not get into this thing because the answer is 0. Now number is not equal to 20. So again we'll go here and then we'll print even number 2. Okay. Now we'll see number becomes 3. Okay. So if the value is 3, so again 3 divided by 2 is not equal to 0. So we'll continue. Okay. We'll skip the odd number. Then the number becomes 4. Again it will come here and it will print 4. Okay. So let me just show you by debugging the program so that it becomes more clear. Okay. I'll just right click and debug loops. Okay. So initially the number is 1. Okay. So we'll check now 1% 2. now is not equal to 0. This condition is true. So it will come and inside this condition will continue. Okay. Next, number becomes 2. Now, see, it came out of this condition because this condition was not true. Now it will check this condition. If number is equal to 20, no, this condition is again not true. So here it will come here and it will print even number 2. 2 continues. Next we have number 3. Now it will check this condition. See, it checks this condition and this condition meets. So it will come here and we'll see continue. So it will skip this part because here with the help of continue we skips this. Now next is 4. So this condition does not meet. Okay, then we'll check num equals to 20. Is this condition true or false? No, it's false. So next it will come here and it will say even number num, even number 4. Okay, and again we'll see loop continues. So this is an easy way to understand better. So whenever you find any difficulty in understanding any program, just debug it and see how that program is internally working. All right. Now let me just comment this out. Okay, so now I'll show you the example of while loop. We'll be building an ATM here. Okay, so let's say I have a balance which is equals to 5,000. Okay, while balance is greater than 0, amount equals to int, we'll ask the user to input the amount, enter amount. Okay, so if amount is not divisible by 100, we'll say print invalid amount and we'll continue. Okay, now if amount is greater than balance, we'll print not enough balance and again we'll continue. Now if balance, we'll deduct the balance, we'll deduct the amount from the balance and we'll print remaining balance. Now if balance is less than equal to 1000, we'll say print low balance stopping and we'll break out of that. And next we'll say session ended. Okay, so this is our ATM. Initially we have taken balance is equals to 5,000. We'll see if the balance is greater than 0, we'll ask the user to input any amount. Okay, so if the amount is not divisible by 100, we'll say invalid amount, because let's say if in our ATM we have cash only in hundreds, let's say 500 note, 100 note. Okay, so we'll say if it is not divisible by 100, we'll say invalid amount and we'll continue. Next, if our amount is greater than balance. Okay, so if our amount is greater than balance, the amount we want to withdraw is greater than what we have in the ATM, we'll say not enough balance. Again, we'll continue. Now, next, if these two conditions are not met, we'll come here, we'll say, okay, balance, we'll deduct the amount from the balance and we'll print the remaining balance. Now, if it happens that balance is less than equal to 1000, we'll print low balance stopping and we'll break out of that loop. Okay, our ATM will not then our ATM will stop withdrawing. Okay, and then last we have session ended. I'll just quickly show you. Okay, it is asking us to withdraw amount. Okay, let's say I withdraw 100 rupees. Okay, so next we remaining, it gives us remaining is, so when I enter amount 100, it first it goes here and it says whether amount is divisible by 100. Yes. Okay, so this condition is not met. Again, if amount is greater than balance, this condition is not met again. So it will come here. It will deduct the amount from the balance and we get remaining balance. So it has printed remaining balance and here our session has ended. Now again, let's say if we enter an amount, let's say this time we enter 1000 rupees. So we had remaining, we'll deduct 1000 from 4900 and we get the output 3900. Okay. Now let's say we enter amount 625. So it says invalid amount. Okay. Let's say I ask ATM to withdraw 4000. Now the amount that is remaining in my ATM is 3900 and I'm asking to withdraw 4000. So it is saying not enough balance, right? Okay. Let's say I ask it to enter 38. I withdraw 3800. Okay. So now it says remaining 100 because now only this is the remaining amount that is left in the ATM after withdrawing 3800, and now it will show us low balance stopping. Okay, so it will break out of that because now we cannot withdraw any more amount. Okay, so I hope this example is clear. Okay, so we have seen the entire first chapter, which is Python revision tool, and we saw all the topics. So Python is a simple interpreted high level language. We saw that programs use tokens, pipe variables and built-in data types. Expressions and statements form the building blocks of program. Then we saw flow control and looping, for loop, while loop. We also saw how to come out of those loops, typecasting, math library. So this basically concludes the chapter 1, and I hope this chapter is clear. If you have faced any difficulty in understanding any topic, please let me know in the comments. Okay, so thank you. Happy learning.